Hey all, so let us discuss the problem number 26 in the quantum mechanics, which talks about the probability density for a particle to lie between x and dx, which is in a state psi x equals to a to the power p dot x divided by h cut plus b e to the power minus I p dot x divided by h cut. It is asked that, so the question is, let me explain you, मैं आपको समझाने की कोशिश करता हूँ. क्वेश्चन ये कह रहा है कि आपको एक अगर वेव फंक्शन ये दिया हुआ है तो प्रोबेबिलिटी डेंसिटी जो है क्या होगी, जो इसके लाई करने के x प्लस dx और x प्लस dx के बीच में, राइट. सो लेट अस डिफाइन फर्स्ट द प्रोबेबिलिटी डेंसिटी. सो व्हाट इज प्रोबेबिलिटी डेंसिटी? सो इफ यू रिमेंबर इट, सो प्रोबेबिलिटी डेंसिटी इज डिफाइंड एज P is defined as psi star psi, right? So this is simple definition of probability density. Now, as this is a complex wave function, so we will take psi star and psi will be different. Now let us take it. The psi star is nothing but the Hermitian conjugate of psi, right? So this. Let us take it. So it will give you A star as we do not know whether A is a real or complex number, right? So we assume it as A star, and its complex conjugate will be minus of I p dot x divided by h cut, right? Plus B star e to the power, this I becomes minus I. So this becomes plus I into p dot x divided by h cut. This is called A star, psi star, multiplied by psi. This is A e to the power I p dot x divided by h cut plus b e to the power minus I p dot x divided by h cut. Right? Now let us take the simple multiplication of these terms one by one. So P gives you A star A is nothing but mod A square, right? This simple definition. A star A is mod A square. So and this minus and plus will give you to the power 0, right? Similarly, now it will give you A star B e to the power minus of 2I p dot x divided by h cut, right? Plus B star A e to the power 2I p dot x divided by h cut plus B star B. This is mod B square e to the power 0, right? So this is straightforward calculation. So it means it gives you mod A square plus mod B square plus this term. Now what is this term? A star B plus B star A gives you mod of AB, right? And just multiply by it 2 and divide by 2, right? Multiply by 2 and divide by 2. What does it gives you? It gives you e to the power 2I p dot x plus e to the power minus of 2I p dot x divided by h cut whole divided by 2. Now if you look at it very carefully, what is this formula is? This is nothing but the formula of cos p dot x divided by h cut. Sorry, cos 2p dot x divided by h cut. Right? So it gives you what? So probability density h mod A mod B cos 2p dot x divided by h hat as a probability density, right? So this is the simple way of doing the calculations and using the formulas, right, for calculating the probability density. Now, if it is asked, this kind of problem we ask in any of the exams, I hope that you will be, there will be no problem to you to calculate the same, right? So please note it down. 7, we say that for a potential barrier of width, height u0 and finite width v, the position space wave function psi x will be oscillatory for n years if and only if energy E of the particle is what? How it is energy of the particle is how related to the barrier width, right? Barrier height. So let us understand the barrier potential. So barrier potential looks like something like this, right? So this is u0 and this is normally v, right? So as you can see that it has like alpha particle decay, it has usually 3 regions. The incident region, it has a reflected one, wave will be there, then again incident transmitted, then again reflected, then again transmitted, right? There will be no further reflection. So these 5 waves will be there, right? Ultimately, depending upon the energy of the particle and the barrier height, the particle will either reflect back or trap inside the barrier or come out of the barrier, right? So here it is saying that height u0 is there and width v is there and E is the energy of the particle. Now if you want a solution which is oscillatory in the psi x for any x, then how E is related with u0? Now you remember that there are 3 cases. First case is when E is less than u0. In that case, you will observe finite probability here. Probability is finite, very small, very small. Alright? Remember that? So this is what we call quantum tunneling. You know that that happens in the basically the model which George Gamow used to describe the alpha decay, right? The effect, the quantum tunneling effect. So in which the alpha particle of very less energy crosses the barrier of very large height, right? This effect, the quantum tunneling is there. Now then, in this case, you will have solution will be something like it crosses the barrier like this, right? With a very small probability, obviously, like this, right? So the probability will be very small, chances. And the second case will be E greater than mu naught, right? In that case, the particle will simply pass through barrier because its energy is greater than the barrier height, right? So it will come out with K, it is E minus u naught, something like this, right? So you can see that obviously you need to check other terms to make it everything correct, which is, but I'm giving you a rough idea that E minus u naught. Now in that case solution will be oscillatory because K is real, right? So If it is either when the solution is oscillatory, when solution is oscillatory, what happens? What happens to energy and barrier height relation? So this is the relation. E must be greater than U naught, right? So this you will remember. So these are some of the important results of barrier potential which you should remember. It can be asked in any other exam, right? Now let us take this problem number 28. So one bolt electron got trapped inside the surface of the metal. A potential barrier is 4 electron volt and the width of the barrier is 2 angstrom. Then the transmission coefficient T is how much, right? So let us calculate the transmission coefficient T. The transmission coefficient T is defined for a barrier potential as 16 E by V 1 minus E by V exponential of minus 2L divided by H cut into 2M into V minus E. Right? So this is the formula we have. Right? 16 E by V 1 minus E by V exponential of minus of 2L by H cut root 2M U naught minus E. Or U naught can be written as V. Now I just try to solve it. 16 E is given, E is the energy and V is this. So 1 by 4, 1 minus 1 by 4, right? This is how much? 4 minus 1, 3 by 4 and 3 by 16. 16 cancels out. So 3. This is how much? 2 angstrom. 2 into 2, right? Into 10 to the power minus 10 divided by H cut, how much? 1.05 into 10 to the power minus 34, right? Into 2 into mass of electron as 9.1 into 10 to the power minus 31 into 4 minus E. 4 minus 1 is 3. 3 electron volt. So this is how much? 3 by 4, 3 by 16 multiplied by 16. Cancelling out exponential. This gives you minus 4 into 10 to the power minus 10 plus 34 divided by 1.05 into 2 into 9.1 into 10 to the power minus 31 into 4 minus 1 electron volt into 1.6 into 10 to the power minus 19. Right? Remember that. So 3 so 19 plus 31 is nothing but 650, right? And 3 into 6. So this gives you a root 6 into 10 to the power minus 50 into 9.1, right? And this minus 4 into 10 to the power 24 divided by 1.05 exponential multiplied by 3. So this gives you some answer which you can further simplify as you will simplify it. It gives you 0.0085 as the answer. Right? This is the answer we have. T is the transmission coefficient. Right? So you should always remember this formula of transmission coefficient through a potential barrier. It will be useful in any of the exams basically a gate need JEST or maybe TIFR For or IISc level, any exam is there, or even in JAM also. You can, it will be here. So now let us discuss this problem number 29, which says that consider a potential state of the form Vx equals to 0 for x less than 0 and v 0 for x greater than or equals to 0. It says that a beam of particle with energy E approaches this potential state form from left, right? Then the reflection coefficient for E less than V naught and E greater than V naught will be what? Right? So let us try to understand the reflection coefficient. Now, if this is a potential step, so this is the potential steps, something look like, right? It is like a ball. A particle is approaching with energy E. Now there can be two conditions. It falls and it gets reflected back, right? Or it gets transmitted, right? This is the only, because there is no further ball to get reflected or transmitted like this. So only transmission will happen. So you will have A, B and C. Remember that A, which is incident, is getting divided into B and C, right, at boundary. So when you apply the boundary condition, you will find that A equals to B plus C. Right? Now it is asked that what is the reflection coefficient for E less than V naught, V naught is this value, and E greater than V naught, right? E less than V naught, what will happen? That particle will not cross the barrier. That's a potential step. It will reflect back only. So in this case, the reflection coefficient, which is defined as the angle of, amplitude of the reflected wave, which is V square divided by incident wave square. So now V, as all the wave which is incident is getting reflected, so B is nearly equals to 1, giving you 1. Right? So in this case, for E less than V naught case, this is the reflection coefficient is almost 1. Remember that. What happens to E greater than V naught? In this case, particle will cross through the barrier and its amplitude will be divided, right? Some of the amplitude will pass through, some of it will get reflected. So the reflected will be R is V square by A square. Now in this case, V square is not equals to A square, but it is less than A square. So which is less than 1. Right? So this is the case. So this you will remember whenever it is asked. Because it will have transmission coefficient also, which will be C square by A square. So when you sum both, reflection and transmission coefficient, it will give you 1. So accordingly, it has been divided. Right? Let's come to one more problem, which says that for an infinite square well potential, if the width of the well is decreases, what happens to the 0 point energy E naught and the momentum uncertainty delta P? Right? So it is saying that infinite square well is there, it means that its potential energy inside the box well is 0, right? So it is something like this. This potential is 0, right? And height of this is potential well is basically infinite, right? And size will be like A 0 to A. You can say it as A, right? So P will be what? Delta P will be greater than or equals to h cut divided by A, right? Or you can say that P will be h cut divided by A, right? So uncertainty will mean in P is always greater than the size of the box, which is the uncertainty, maximum uncertainty the particle can have in the position, right? So It simply means if this is decreasing, then this is increasing. Right? Now, as it increases, you have 0 point energy E, which is delta, which we assume that kinetic part as delta P squared divided by 2m, plus Vx is 0, which is 0, right? So it is directly proportional to P, uncertainty in P. So greater the uncertainty in P, greater the energy, right? So E also increases. Right? So if variable width, potential width is decreasing, delta uncertainty, momentum uncertainty, and 0 point energy both will increase. Remember that. If it is this type of question is asked anywhere, you can look for this kind of arguments, and you can based on these arguments you can simply answer this question, right?